Alright, welcome everyone. Okay, so this is the next video in our unit on stoichiometry. So let's look at what we've got so far. Let's see, we started way back here. Alright, so we reviewed. We know what an equation is, we know how to balance equations, we know what all these things, all these numbers and symbols are. And then you practiced balancing equations. Okay, and then we reviewed what a mole and a mass, what moles and masses were, and there were some questions for you to answer on the in your Google Classroom. And then we talked about molar mass and how to use it to convert, which is you need to remember this for today's lesson. Okay, remember to find molar mass. You add up the masses of the individual elements in the compound, and we can use that as a converter, convert grams to moles, or we can convert moles to grams. Okay, so you have those in your notes. And then we learned what a mole ratio was. It comes from the balanced equation. We use it as a recipe. It's another converter, so it converts the moles that you are given in the problem or what you have into the moles of the thing that you want. What the question is asking for. Okay, and then we had some practice problems. Well, these were the ones that we did together. And then we did some practice. Okay, and I went over some of these in the tutoring session. And then you had even more practice. You're going to turn those in. Okay, and now we are going to talk about the stoichiometry that we usually do in chemistry, and it's mass to mass, and we can't really use mole to mole in real chemistry because we don't start out with moles. We start out with an amount of a substance, and that amount we measure in grams. So we have to convert that. All right, so I'm going to show you, this is the general picture of mass to mass. Okay, so in mole-to-mole stoichiometry, okay, the mole ratio is the central idea. This is, you have to have a mole ratio, and we get this from the coefficients of the balanced equation. So whenever you do stoichiometry, you have to have a balanced equation, and you're going to use the mole ratio. And the way you use it is, you start out with moles of what's given in the problem. So let's call this our have. This is what we have. And then we're going to end up with the moles of what we're seeking. Okay, so we'll call this our want. And you're going to multiply these two, to get that. And by the way, this mole ratio, you can think of it as want over have. Want over have, okay? And this whole thing is what we're doing on the BCA chart. Okay, now for mass to mass stoichiometry problems, you're gonna keep that central part. In other words, you're going to still have your mole ratio, and that means you're going to have your moles, the stuff you have, of the stuff you have, and then moles of what you want to get, and this is still going to can still be done on the BCA chart, but you're going to start out with mass of what you have. Now to get from here to there, to get from the mass that is given in the problem, you've got to convert it. So you're going to use the molar mass converter, which we've already learned about. molar mass as your converter. Okay, so you have some amount of grams here. You're going to use molar mass to get the number of moles, and then you can do what we've already learned how to do using the mole ratio. So you have your moles of what you have. You're going to multiply it by your mole ratio. That's going to get you your moles of what you want, and this is all. You can get this all in your BCA chart, or you can just do the conversion, the calculation. And then the problem is probably going to ask you for the mass of what you want. Okay, and then once again, to get from here to there, you're going to use molar mass converter. Okay, all right, so let's do a practice problem, and we're going to do number 1 on the worksheet that you have in your Google Classroom. Let's put this over here. Okay, so in this problem, let me see if I can zoom, see a little better. Okay, so we have a typical mass-to-mass stoichiometry problem. Determine the mass of lithium hydroxide. That's this one. Right? That one. Determine the mass of lithium hydroxide produced when 0.38 grams of lithium nitrate, that's this one. So we have 0.38, I'm going to put that right here, just so I can keep track. Okay. Of lithium nitride reacts with water according to the following equation. Alright, so we have this, and we want this, and we want it in grams, right? It's asking for mass. So this is a mass-to-mass stoichiometry. So the first step is, so we have this, we need to get to that. So what we have to do is use molar mass to do the conversion. So my first step is to take 0.38 grams of lithium nitride, and I'm going to use the molar mass, which I've already figured out. Remember, you add up all the elements in here and the ratio that's shown in the formula. So one of these, one of those, one of those, and I get 23.98 grams. So I'm going to put that 23.98 grams down here, and the 1 mole on top. Remember, the molar mass is always the mass of 1 mole. And when I set it up this way, grams will cancel, and I do my calculation. Okay, so I have 0.38, and I'm going to divide it by 23.98. It's on the bottom, so you divide it. Equals, and I get 0.0158. Okay, and that's moles of I did the wrong molar mass. Okay. Notice I'm writing these down, and that's my double check. So I need to put 34.83 there. 0.38 divided by 34.83, and I get 0.0109. Okay, so that's how many moles of lithium nitride I have. And now I can put that right here. That's what I started out with, 0.0109. Okay, and they're asking me, I'm going to react all of this. Okay, and I'm trying to find the mass of lithium hydroxide. So this is the thing I want to find. So why don't we just start with this right here. So we're going to use our mole ratio, which is a 3:1 ratio. Right? So I'm starting with 0.0109 moles of lithium nitride. And now we're on this step, right? We have this. We're going to use the mole ratio to find that. Okay, and it's a 3-to-1 ratio. 3 of these, LiOH, to 1 of those, Li3N, and let's double check. Li3N cancels out, and I'm going to be left with moles of this. So I'm going to take this times that. I already have that in my calculator. Times 3, and I get 0.0327 moles of LiOH. Okay, 0.0327. It's a 3-to-1 ratio. Okay, this is 3 times more than that, right? Just like 3 times more than that in the formula. in the equation. Okay, now I am here, and the question is asking for this, so I've got to use my molar mass converter to do that. So I need my molar mass of this, which now I can use this one. So I'm going to take this, and I'm going to multiply it by, this time the 1 mole is going to go on the bottom, because I want moles to cancel. 23.98 grams here. Okay, so I already have this on my calculator. I'm going to multiply it by this number here, times 23.98, and I get 0.78 grams of LiOH. Right, this was LiOH. Yep. And this is my answer. Okay, so you may be asking, okay, do I have to fill in all of this? No, you don't have to fill all of this in. Okay, but from our work last time, you know how to fill all this in. So a question might, ask for 2 things, and you'll know just to fill in the rest of the BCA chart to help you with that. Okay, when in future lessons, when we talked about limiting reactants, you might have to fill in more than these few boxes. Okay, but for now, for the rest of this, you don't have to fill in the rest of the BCA chart. I'm confident that you know how to do that if you need to. Okay, guys. So if you are confused, remember, check into office hours. You can get live help from me. All right, thanks for listening.